a matrix ODE plus eigenvalue, eigenvector matrices. Now, we're starting with eigenvalue, eigenvectors because they're much more simplified ways to look at things before we go to the derivatives and everything, which would be more confusing, but also use eigenvalues and eigenvectors. So it's first. That's what I'm trying to say. Now, over here is the clean version of what's above here. So this is index notation of this. We've seen this multiple times, so I don't really mind just skipping over it because we've seen that multiple times. We'll just move on to the next section over here where we do the new stuff. Now, we know this portion over here, but the eigenvalue and eigenvector comes up from this section over here. This over here, this lambda, is the eigenvalue. It's the eigenvalue. Eigenvector is the v, eigenv vector. So from that, you can kind of see where I'm going over here. Now we're going to see this is true. This is just rehashing this whole entire thing to make it more palatable. So this is also a true statement. And after that, we go into here and say which one of these can be zero, because this parentheses means either this can be zero or this vector can be zero. The vector being zero is very boring. We don't have to discuss that too much. It just is a boring answer. No one cares about it. Now, this, on the other hand, matters. Now, we take a determinant because this determinant might change the other things, but it doesn't change the lambda. The lambda has to be the same no matter what because it's just lambda. It's a constant, it's a scalar. It can't change from just doing a determinant. So solve this and you get the eigenvalue. And we'll give you an example over here and how you can actually use it. So you get an A over here. You do the same steps and get the determinant. You solve that, whack polynomial to get these roots. And those roots just plug back to the original format over here. And the original format was this format over here. So we use that. Instead, we use x and y. The reason we use x and y is because v1 and v2 is discovered in a different way. Discovered by looking at this and say 1, 1, and then that's 1 equal 2 or something. And then we see that over here, and we say we give that over here, and we keep on expanding on it because the lambda is just a constant from it, and lambda is a constant over here. And we see that over here. And then there's another proof over here, but that doesn't really matter. I'm just here for the eigenvector and eigenvalue, simply showing that. We have no other excuse to show that, and that's it. Other than that, we have really big ODE questions with derivatives that actually use that property, but that's for a longer format video. I just want to show you that it's possible to use in real life, and we're done.